In this lesson, you're going to find out how to find equivalent ratios. How do I simplify ratios? Simplify the ratio 4 to 10. Well, to simplify the ratio of 4 to 10, I ask myself, is there a number that can go into 4 that can also go into 10? And that number is 2. So I say 4 divided by 2 is 2. 10 divided by 2 is 5. It's just like when we would simplify 4 tenths. I'd ask myself, well, what would go into 4 that would go into 10? And that answer is 2, leaving me with 2 fifths. So the simplified form of the ratio 4 to 10 is 2 to 5. How do I know if two ratios are equivalent? Well, two ratios are equivalent if they are simplified down to lowest terms. They are going to be equal. So let's take a look here. 4 fifths cannot be simplified, so I'm just going to circle that one. But 12 fifteenths can be simplified. 3 can go into 12 and 3 can go into 15. So down to simplified form, we're going to have 4 fifths. Well, 4 fifths is equal to 4 fifths, so yes, these two ratios are equivalent. Okay, another method to finding out if two ratios are equivalent is to find their cross products. So I could take 4 times 15, and that's going to give me 60. And 15 times 5 is going to give me 60. So as you can see, by finding the cross products, these two are equivalent. Another way you could find out if these two ratios are equivalent is by just asking yourself, is there a number that I can take from 4 to go to 12? Or I could say 12 divided by 4. So what did I do to go from 4 to 12? I multiplied that by 3. So how do I go from 5 to 15? I would multiply that by 3. So since 4 times 3 is 12 and 5 times 3 is 15, we know that yes, these are equivalent. All right, the fourth method in finding out if two ratios are equivalent is by changing them into a decimal. I can take 4 and divide it by 5 on the calculator, and I'm going to get 0.16. And if I do the same with 12 divided by 15, I'm going to get 0.16. So there are a few different ways of finding out if two ratios are equivalent. And it really doesn't matter which method you use. It might depend on whether or not you're able to use a calculator or not, or if one ratio can be brought evenly into the other ratio. So here are some new numbers. Are these two ratios equivalent? Well, it doesn't matter which method I use. In this case, I think I'm just going to take, and I'm going to have 6 and put it all over 12, and I'll take 18 and put that all over 24. And let's say I just wanted to simplify it. All right, 18 can be divided by 6, and so can 24, leaving me with 3/4. So are these two ratios equivalent? No. So how do I find the equivalent ratio? I have 4 to 9 is equal to 12 to, well, I don't know. One method you could use, in this case, it's easy to see that I went from 4 to 12 by multiplying the top number by 3. So if I did that on the top, I'd have to do that on the bottom, leaving 4/9 is equal to 12/27. All right, in this example, it's not as easy to see what number times 4 is equal to 10. So I might want to use another method called cross products. In this case, if I'm going to do that, I might want to give that question mark a variable. So now I'm going to take cross products, meaning I'm going to multiply across. So I take 4 times x, which is 4x, and I would take 8 times 10, which is equal to 80. Now we need to isolate this variable, and right now 4 is multiplying x, so to undo that I'm going to divide by 4, and x is going to be equal to 20. So if you wanted to check to see if you did this one right, let's just put 20 down here. 4/8 in simplified terms, I'd have to divide by 4. I'd have 1/2. Is that equal to 1/2? Yep, I did it right. So my term is 20. So how do I apply equivalent ratios to real-world situations? In my first example here, it says that Jennifer planted 5 trees in 2 hours. How many trees did she plant in 6 hours? So what I want to do is I want to write this ratio of 5 trees in 2 hours. So now I don't want to know what it's going to be for 2 hours. I want to know what it means for 6 hours. Now notice that hours and hours, your time there is lined up. Same with the number of trees. Well, I know how many trees I can do in 2 hours, but I don't know how many trees I can plant in 6 hours. In this case, it's kind of easy for us to see how did I go from 2 hours to 6 hours. Well, I multiplied it by 3. So if I do that on the bottom, I have to do that on the top, meaning that I can plant 15 trees in 6 hours. So in my last example here, I have a recipe that calls for 2 cans of juice to 3 cans of soda. How many cans of juice would I need if I had 9 cans of soda? So I'll go ahead and I'll rate this as a ratio of 2 cans of juice to 3 cans of soda. So I'll have 2 juice to 3 soda. And it's important that you label your parts of your ratio so that you can get them lined up. So now it wants to know, well, how about if I have 9 cans of soda, how many cans of juice would I need? Well, because I have then 9 cans of soda and I've got soda down below here, I need to put my 9 soda down below. And then what I'm solving for is the amount of juice. So that's lined up as well. Well, this one's kind of easy for us to see. That how do I go from 3 soda to 9 soda? I'd multiply by 3. But maybe I want to take a look at how I would do it in cross products, just so we can have another look at that. So if I were going to use my cross products, I would then have 3 times x, which would give me 3x, is equal to 9 times 2, which is 18. So I'm going to isolate the variable by dividing by 3, and x is going to be equal to 6. So for every 9 cans of soda then, I would need 6 cans of juice. So today we took a look at how you can simplify and find equivalent ratios.